Welcome to Math 1324, Section 8.3. We continue to look at probability. What's new in this section is something called conditional probability. Usually this occurs whenever we chain together two actions. For example, I'm going to pick two cards from a deck of cards. I pick one card, look at what I have, and then I pick a second card. Now, if you think about it, if I did not put the first card back in the deck, then when I picked the second card, the number of cards left in there is 52 minus 1, which is 51. So conditional probability looks at what happens if one event, when it happens, changes the number of outcomes for the next one. Okay, so let's see. Here we have a single card is drawn from a 52 card deck. Find the conditional probability that the card is a spade given that it's a king. Now you can get into all the fancy formulas, but the secret is given we know it's a king. Well, how many kings are in the deck of cards? There's only 4 of them. So my sample space really is only 4 at that point, because I know it has to be a king. And now what's the probability that of these 4 cards, it's a king? Well, if you think about the kings, there's a king of diamonds, a king of hearts, a king of clubs, and a king of spades. So there's only one spade in the 4. And so that is our conditional probability. The book sort of steps you through this. The probability that it's a spade is 13 out of 52. And it's a king, well, there's 4 out of 52, or 1 out of 13. Okay, question 2. Again, a single card is drawn. Find the conditional probability that the card is black, given that it's a spade. So I know whatever this card is, it's a spade. So what's the probability that the card is black, given that it's a spade? Well, spades are black cards. So there's a 100% chance, or 13 out of 13, that the card is black, given that it's a spade. In question 3, a single card is drawn again. Find the conditional probability that the card is a spade, given that it is black. All right, well, let's see. Now, it's not 1 again like in the previous problem, because if I know it's a black card, there are 26 of them. 13 of those are spades and 13 are clubs. So the probability that it's a spade is 13 out of 26, or 1 out of 2. In question 4, first off, I want to find the probability of M intersect S. Well, that's the same as saying the probability of M and S. So M and S is this branch of the tree. And so to answer the problem, we simply multiply together the probabilities along that path. And so it's 0.8 times 0.8, which is 0.64. And in the second part of this, find the probability that it is R. Well, how do I get R? Well, notice R is here at the end of two different branches. So to find the probability of R, I simply trace down each path and then add up those numbers. So going down the first path, it's 0.8 times 0.2, which is 0.16. And then if I go down this other path to get to R, it's 0.2 times 0.7, which is 0.14. We add those together and we get 0.30. So again, conditional probability, we're looking to see if the first event causes the numbers to change for the second event.